Hi everyone, this is a video on variables and expressions. The objective for this lesson is to be able to write mathematical expressions for verbal expressions and vice versa. The focus question is, how is an algebraic expression different from a numerical expression? Vocabulary for this lesson is quantity, variable, algebraic expression, numerical expression, and power or exponent. Those two terms are interchangeable. Quantity is anything that can be measured or counted. So the number of pencils that you have, or the number of siblings you have, or the amount it rained yesterday. A variable is a letter that represents the values of a quantity, or in other words, a variable is a letter that represents a number or numbers. An algebraic expression is a mathematical phrase that includes one or more variables. So an algebraic expression, think about algebra or alphabet, it has a letter in it. A numerical expression is a mathematical phrase involving numbers and operation symbols, but no variables. So only numbers. So numerical, numbers. Power or exponent is an expression that represents repeated multiplication of the same factor, and a factor is a number. And that's something that you guys have seen before in your previous math classes. It's just something that we're going to review. Warm-up. So consider the population of Florida, the area of Colorado, and the flight time from Philadelphia to San Francisco. Which of these has a value that varies? So I want to give you guys a couple minutes to think about that. To translate word phrases into algebraic expressions, look for words that describe mathematical operations. So we're going to translate word phrases into algebraic expressions, and this is a table that will help you with that. So the operation, several words can represent different operations. So this is just a table showing you which words go with which operation. And these words, there are more words than this, obviously, but these are the most common ones that we will see throughout the problems or expressions that we'll see through this lesson. And then this is the algebraic expression. So 5 plus x or x plus 5, that can be interchangeable. And the word phrase. So the sum of 5 and a number x would be represented as 5 plus x because sum means add. And I'm going to jump to multiplication. When you see 4 and then the dot in the middle and then y, or even 4 dot and a number, remember that that dot means multiply. Also, 4x times y, everybody knows that that means multiply. And then if you see a letter and a number right next to each other, that means multiply as well. And when you see a fraction, so n over 2, remember that means divide as well. Translating verbal expressions into algebraic expressions. So an example would be 4 more than a number y. So the verbal expression is 3 more than a number y. So the algebraic expression, remember, it has a letter in it, so it's 4 plus y, because more than means add. So here are some sample problems. You're going to write each expression algebraically. So the product of 7 and a number x. So this is an example. We'll do the first one together. So the answer is 7x if you write it algebraically, because the product means multiply. of 7 and a number x. So a number, that means it can be any number. X is representing that number. So 7 times x. So the difference between 15 and y squared. That would be 15 minus y squared. So remember that squared means the exponent 2. Okay? If it was cubed, cubed would be 3. The sum of 4 and m. So sum means add, so 4 plus m means the sum of 4 and m. T divided by 3. The answer is t divided by 3. You can also have t over 3. You could not put 3 over t because if you put 3 over t, then that would mean 3 divided by t. And that wouldn't be correct. So it would be t over 3 or t, the division symbol, 3. 4 times 7 plus n. This one has more than one operation and numbers in it. So this would be represented as 4 parentheses 7 plus n because it says 4 times 7 plus n. So you want 7 plus n and 4 times whatever that that equals. So 7 plus n and then you multiply it times 4. Now we're going to do the opposite and translate algebraic expressions into verbal expressions. So an example would be 4m, or 4 times m. So the algebraic expression would be 5 times m. And the verbal expression would be 5 times a number m. And it's important to put a number in there because a number represents, that means that m can be any number. It's the variable that varies depending on what it is. So 5 times a number m. And then we would say the product of 5 and m. So write a verbal expression for each algebraic expression. So 4 minus t. So the algebraic expression would be the difference between 4 and t. Because difference means minus. And 4, you have to put the 4 first because it wants to know the difference between 4 and t, not t and 4. X plus 8. The sum of x and 8. So sum means add x and 8. C divided by, 3 divided by s. The ratio between 3 and s. So ratio is another term for divide. To z, the product of 2 and z. Product means multiply, and then 2 and z. 21d minus 4. And this would be, if I can get this to minimize. the difference between 21 times d. So the difference is minus, and then 21 times d and 4. So you want to know what 21 times d is before you can subtract 4 from that product. Power is an expression that represents repeated multiplication of the same factor or number. So where x times n, or x to the nth power, so x is the base and n is the exponent, which corresponds to the number of times the base is used as a factor. So this is just a chart to show you the difference between the types of exponents and what they're called, or the power, and then what it looks like, the meaning of it. So 2 to the second power, or 2 squared, you're doing 2 times 2. You're not, and then 2 cubed, or 2 to the third power, you're not multiplying 2 times 3. You're multiplying 2 by itself 3 times. So 2 times 2 is 4, times 2 is 8. Not 2 times 3 is 6. And then down here, you can see 2 n to the 6. So 2 times n to the 6th power is how that would be read. And then you would multiply 2 times n 6 times is the meaning. So an example is 2 to the 6th power. So the power is, the exponent is in blue and the base is in red, and you're multiplying 2 by itself 6 times to get 64. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 6 factors of 2 is a way that could be expressed using words. So find each value. So 2 to the second power. So your answer would be 2 times 2, which is 4. 3 to the third power, or 3 cubed, would be 3 times 3 times 3 equals 27. 4 squared, or 4 to the second power, would be 4 times 4 equals 16. So you're multiplying 4 by itself twice. D squared, 7 squared, or 7 to the second power, is 7 times 7, which would be 49. And then 1 to the fourth power would be 1 times itself 4 times, and you still get 1.